Hi there, my name is Allison Payne, and I'm a PhD student at the University of California, Santa Cruz, and I'm really excited today to talk to you about my dissertation work. So the lab I'm in studies elephant seals, and one kind of surprising gap that we have in our knowledge of elephant seals is how they find their prey. So most other animals in the deep sea are finding prey based on echolocation. We know that seals can hear echolocation. They have good high frequency hearing, but they don't actually echolocate or vocalize underwater themselves. At a broad scale, we know they use memory to return to foraging areas they've been to before, and that they can use whiskers to actually track down the prey. That's what this little video is of. But how do they make foraging decisions in between those scales? In terrestrial systems, we get a lot of animals that listen to each other in order to get information. And so we wondered if this could be happening in the deep sea as well. Could seals be eavesdropping on echolocating sperm whales, for example? So to test this, we instrumented an elephant seal with biologging devices that allowed us to track location and diving behavior, as well as the soundscape of her foraging trip. So first, we can use the location sensors to see if seals change their movement behavior in response to echolocation. So we're looking for something like transit followed by foraging area restricted search. We should also see changes in diving behavior if there are good foraging opportunities. So the time spent at the bottom of the dive where it's foraging should get longer. And finally, if seals are moving towards the sounds of odontocetes, then we should see an increase in the received level of the sound, which essentially just means how loud the sound is. So that should get louder if the seal is moving towards the sperm whale. So what we saw was that the seal's trip split into a travel phase and a foraging phase. Her movement persistence started out high and dropped over the course of the encounter, especially when sperm whales were present. She reached a foraging area off Coos Bay, Oregon, where she stayed for multiple weeks, overlapping with sperm whales about 1/3 of the time. And in this part of the trip, her movement persistence was low, which means that she was foraging. As we predicted, seals spent longer at the bottom of dives when sperm whales were present, indicating that they were in a good area for food. And when the seal first heard sperm whales, the received level of the clicks increased over about 4 hours, consistent with what we would expect if the seal was investigating a cue. So together, this all shows that echolocation might be an important signpost in a relatively featureless deep sea, and human impacts like shipping noise and deep sea mining might impact these communities in ways that we don't even know about yet. Thank you so much for listening.